In this lecture, I will explain what is a leakage reactant of single phase transformer. So in the previous lecture, we considered that primary winding and secondary winding has a resistance. In this, we will consider only reactance, that is a leakage reactance. So what is meant by leakage reactance, how it is formed? Now I will tell you. These two are the limbs. This is a core type of transformer. In a core type of transformer, we wound the winding like this. This is a primary winding, and this one is secondary winding. Actually, the limb size will be same. The leakage reactance will be represented with the X1. The secondary winding leakage reactance is X2. Now, what is meant by leakage reactance? Whenever we are giving a sinusoidal supply and alternating current is flowing through the coil, this will produce an alternating flux in the transformer core. This flux will be linking with the primary winding and secondary winding. Due to this, an EMF is induced in a primary as well as the secondary winding. Some part of the flux is passes through the air. Some part of the flux is passes through the air at limb 1. At limb 2 is also some part of the flux is passes through the air. This flux is called the leakage flux. The flux which links either primary winding or the secondary winding, but not both the windings, is called the leakage flux. So here, as this leakage flux depends upon the load current. As load current increases, the leakage flux in the primary winding and secondary winding both are increases. We can say that phi L1 is called the primary leakage flux, primary side leakage flux, and phi L2 is secondary side leakage flux. So here, due to this leakage flux, we know that inductance is equal to N into phi divided by I. This is the inductance formula. Now the leakage inductance can be defined as N into phi L1 by I1. This is L1. L2 is N2 into phi L2 divided by I2. So due to this, we are having a reactance, that is X1 2 pi F into L1, and X2 is 2 pi F into L2. So this is called the leakage reactance of the primary, or leakage reactance of the primary. This is a leakage reactance on secondary side. So we know that from the previous lecture, R01 is equal to R1 plus R2 dash, that is R1 plus R2 by K square. X01 is equals R02 is equal to R2 plus R1 dash, that is R2 plus K square times of R1. Similarly, due to this leakage flux, an EMF is induced. That leakage EMF is EL1, and here also the leakage EMF is produced, that is EL2. If you draw the phasor diagram, so this is V1 and magnetizing component of current, the flux wattful component of current, the resultant current is our no load current, the angle between flux and induced EMFs are 90 degrees. So with respect to E2, V2 is lagging at an angle of delta, that is a small angle. For a lagging power factor of the load, the I2 is lagging at an angle of phi2. There is a reflected coefficient on the primary side, that is I2 dash. By adding these two vectors, then I got the resultant current. That resultant current is called the I1. Now here, due to this I1, leakage flux will be produced. That leakage flux will be phi L1. Due to I2, the leakage flux phi L2 is produced. If I2 increases, I1 is also increases. So with respect to phi L1, the EMF will be induced. The EMF is induced, that is 90 degrees with respect to flux. This one is called the EL1, is exactly 90 degrees to the I1. And here also, if you observe, with respect to phi L2, the E2 is 90 degrees. This is called the EL2. Suppose if you observe the 100% of the flux is present, 5% of the flux will be leaked. So on primary side and secondary side, only 90% of the flux is present. That is common for both the windings. We can't say the flux which is common to both the windings is called leakage flux. It is a useful flux. The flux which links either primary winding or the secondary winding, but not both the windings, is called the leakage flux. So this you know that phi 1, and this is called the phi 0, right? Okay. So similarly, x01 is equal to x1 plus x2 dash, x1 plus x2 divided by k square, and x02 is equal to x2 plus x1 dash, it is x2 plus k square times of x1. So the primary winding has a leakage reactance of x1, and the secondary winding has a leakage reactance is x2. The current which is flowing through this load is I2. The current drawn from the supply is I1. The supply voltage is V. If you want to shift this secondary winding leakage reactance to primary side, now it will becomes x2 dash. So now it will becomes x2 dash. So this is the same story what we have discussed in the previous lecture. So directly I am writing total reactance when referred to total leakage reactance. Total leakage reactance when referred to primary is equal to x1 plus x2 dash x1 plus x2 divided by k square. Suppose if a primary winding leakage reactance is shifted to secondary side, that will becomes x1 dash. So now it will be shifted, right? This is x2 dash, x1 dash and x2. This is connected to the load. The current which is flowing through is I2. This one is I1. This is the sinusoidal voltage. See, the secondary winding leakage reactance is shifted to primary side, that will becomes x2 dash. If the primary winding leakage reactance is shifted to secondary side, that will becomes x1 dash. Now the total leakage reactance when referred to secondary is equal to x2 plus x1 dash x2 plus k square times of x1. If we are considering the resistance and leakage reactance of the primary winding, so this is winding resistance and leakage reactance when the winding is that is called the primary. This is R2 and X2. So this we can say that it is a Z02 total impedance. This is Z01 impedance of the primary and impedance of the secondary. So if all are shifted to secondary side parameters are shifted to primary side, R2 becomes R2 dash and X2 becomes X2 dash. X2 becomes X2 dash. The current is I2. Now the total resistance is R01 is R1 plus R2 dash and X01 is X1 plus X2 dash. In this case, Z01 is equal to R1 plus J times of X1 and Z02 is equal to R2 plus J times of X2, and the total impedance when referred to primary, that is R01 plus J X01. If primary side parameters are shifted to secondary side, the primary side parameters are shifted to secondary side. So this is R1 dash, leakage reactance is X1 dash, and the resistance of the secondary is R2, leakage reactance is X2. This is I2 and I1. So R02 is equal to now R2 plus R1 dash, total resistance when referred to secondary, R2 plus K square times of R1. And the leakage reactance, total leakage reactance when referred to secondary is X2 plus X1 dash, that is X2 plus K square times of X1. And the impedance, total impedance when referred to secondary, R02 plus J times of X02. Once again I am explaining what is meant by leakage reactance. Means leakage flux. The flux which links either flux primary winding or the secondary winding but not both the windings is called the leakage flux. This leakage flux is depend on the load current. As the load current increases, the leakage flux in the secondary winding increases. It will draw the additional current. The leakage flux in the primary winding is also increases. See, this flux, main field flux will depends upon the maximum flux density. This main field flux which is independent of the load current, almost small changes will be occurred. Due to this leakage flux, an EMF is induced, that is called the EL1, that is exactly 90 degrees to the phi L1, and both I1, the primary current, and leakage flux are both are is in same phase, and with respect to phi L1, EL1 is 90 degrees lagging. So phi L1 is called the primary side leakage flux. This is called the secondary side leakage flux. Due to this, we have an inductance. L1 is equal to N1 into phi L1 I1. L2 is equal to N2 into phi L2 into I2. After that, leakage reactance is formed. That is of the primary and as well as the secondary. So now the resistance are shifted from one side to another side. We are already derived total resistance when referred to primary is R1 plus R2 dash, R1 plus R2 by K square. Total resistance when referred to secondary is R2 plus R1 dash, that is R2 plus K square times of R1, and X01 is equal to X1 plus X2 dash. Similarly, X1 plus X2 by K square. And now I am shifting the leakage reactance from secondary to primary and primary to secondary. Then I got the relationship X01 and X02. That means the total leakage reactance when referred to primary, the total leakage reactance when referred to secondary. In this, we are considering the resistance and as well as the leakage reactance. Resistance and as well as the leakage reactance. After that, Z01 is impedance, total impedance when referred to primary. Z02 is the total impedance when referred to secondary. So Z02 here, Z02 is equal to R02 plus JX02. R01 is equal to, you know the formula, and Z01 is equal to R01 plus JX01.